Hello everyone. So right now I'm going to discuss a topic called as method references inside the Java language. So as part of Java 8 features series, I made sessions about default and static methods inside the interfaces, and then I made one more session about the functional interfaces and as well as lambda expressions. So extended to those topics, we have one more concept called as method references in Java. So that means, like however we discussed earlier, the importance of Java 8 features usage in our real-time applications nowadays with respect to functional programming, and as well as with respect to interview oriented also, we used to encounter nowadays the entire Java 8 feature related questions or topics, whatever it is. By considering all these scenarios, I'm going to discuss more details about the method references feature as part of Java. So generally, method references is somewhat extended to the functional interfaces as well as lambda expressions concepts. So that means we have to understand what exactly the meaning of method reference is and how it is related to functional interfaces as well as lambda expressions. Okay, it means we required knowledge of functional interfaces and lambda expressions to understand the method references. I just provided in the description the details of functional interfaces and lambda expression sessions. Okay, now let's come back to the method references. So now the agenda of this session is I'm going to explain what is method references and how method references are related to the functional interfaces as well as lambda expressions. We will try to have a couple of scenarios. How many types or how many ways we can use method references in our programming, as well as I will try to take a couple of use cases of method references like with practical examples. Okay, so let's start the more details about the method references now. Generally, the method references are called as a special type of lambda expressions. So what is the meaning of a special type of lambda expressions? Why we are calling method references are a special type of lambda expressions? So generally, when we will define the lambda expressions, when we are having a functional interface and when we are providing implementation to the functional interface, abstract method, so instead of defining the abstract method details and all, we are directly defining it as an expression by using some lambda signature. We are defining the implementation of abstract method. Let's create a functional interface, and for that functional interface, we will define a lambda expression. And from that, we will define a method references concept. So I'm defining a functional interface here, and the name is convert to uppercase. So this is what my functional interface name. So I'm just marking this interface as a functional interface so that we have to provide one abstract method mandatory. And I'm expecting my result should be string, and once the value is converted to uppercase. Okay, now as part of functional interface, I defined one abstract method called as converted to uppercase. It is taking string value and then it has to produce again a string value as a return value, right? So let's define a lambda expression implementation for this. Okay, let me define a class here. Okay, now I just defined a main method class, and what I'm doing, I'm providing implementation for this abstract method with the concept called as lambda expression. So generally what we will do as part of lambda expression, we will take the interface reference, okay, convert to uppercase. So I'm just taking reference as uppercase equal to, so here we will define the lambda expression based on the abstract method signature. So as part of this method signature, you have one method parameter. So what you're going to do as part of our lambda expression definition point of view, you can take one variable here, right? So I'm just taking value and then followed by, that means implementation of lambda expression and curly braces, and I'm going to close this, and you know that it is expecting a return value something like string. So I'm just right now I'm just dealing with the null. I'll replace it. Okay, so as part of this, what is our intention? So let's assume you return, you know that value belongs to which data type? String data type. Value dot to uppercase. So your aim here it is what? See, I just taken very small example. Okay. First of all, to make sure everything is clear with respect to method references. So you created a lambda expression. You implemented logic for the abstract method of lambda expression, and you are making whatever the string value it is coming, you are just converting as a uppercase. Now, generally, how we are going to execute this again? So if you or if I am writing sys out of, okay, and what is the reference name here you have? This is the reference name dot, and the abstract method name what you written converted to uppercase. Now here I am writing, okay, a statement called as Java method references, right? So now see, this entire string has to be is going to be converted as uppercase, and that value will be written by executing this lambda expression. So I'm writing this out here also. So inside lambda notation, converting value to uppercase. So just making sure the lambda expression is executing or not. So let's execute now. What is going to happen with this execution? It's all expected result with respect to functional interface and lambda expression. So you define functional interface, and by using lambda expression provided implementation of abstract method. Now we are executed and we got everything is converted as uppercase. So that is fine. With respect to lambda expression, you define and you provided implementation for the abstract method and all. But if you observe here, we are using a predefined method from the string class as part of lambda expression, right? So that means to utilize the existing predefined method or user defined method which is already available, okay, why we have to take again a lambda expression, and inside that we have to define our logic to fulfill the requirement point of view. So that is what the concept of method references here it is. The method references is saying, like in a short, we have to reuse or utilize the existing method implementations which are suitable or which are compatible to the functional interface implementation of abstract method. So that means now our functional interface aim is converting to the uppercase, and we define a abstract method like taking one string value and converting as uppercase and returning a string value, right? So now same kind of method we are already having inside a string class as a predefined method, right? So instead of again declaring a lambda expression, okay, you just reuse that existing predefined method of the string class, okay, by using a concept called as method reference. So that means it's all about reusing of existing implementations. What are the predefined methods or user defined methods we have? Okay, so if you take in method references here, how I am going to write down the same solution whatever I implemented as part of the interface, functional interface, with respect to method references, understand here. So I'm taking again the same reference converted to uppercase, okay, and I'm just taking a reference variable name again as called as uppercase 2, a reference variable name, and equal to, if you observe earlier what we discussed, a point called as, we understood like method references are a special type of lambda expressions. That means we define lambda expression with the logic whatever we want here finally to make sure converting string value to the uppercase. But if you see here what I am doing, I'm just calling string colon colon, and I'm calling the predefined method whatever available inside the string class called as to uppercase, and I just assign this to the reference of the functional interface. So that means this is also one way of solution to define functional interface implementation. When you are already having solution as part of a method, we are just reusing that method. Now let's see, if I am writing same statement whatever I written earlier, okay, even if I use the same thing with respect to the current solution instance, okay, see here the current instance I am taking here, and I'm just converting same example one more time as a Java method references. Now let's see the output what you are going to get here. So run as Java application. So that means you got the same output here also, and when you are using lambda expressions also, we got the same result here. Then what is the main difference between lambda expressions and method references when it comes to functional interfaces is the lambda expression is simply saying like you have to implement logic with the lambda expression solution. But method references is saying like when you're already having a solution as part of one existing method, whether it is a predefined method or user defined method, the solution is compatible to your functional interface abstract method, then you no need to define again a separate lambda expression like this. Simply you can define that method reference, that method. So that means this is the predefined method name available under the string class, and I'm using a method reference delimiter. So that means we used to use a double colon symbol here, and this will be called as method reference delimiter. Method reference delimiter. So this double colon you have to use. So that means prefix of this double colon is representing, okay, whether it is a class name or instance reference. Generally the syntax I am telling you, and we will take examples also for everything, and followed by colon colon, and whatever the method you are trying to invoke from the that functional interface abstract method implementation point of view, that method name you have to define as part of this colon symbol, double colon symbol. And you don't need to define any parentheses here. It's all internally compiler will take care or JVM will take care internally. So that means very simple. So in this case, if you are using method references, what you are trying to say to the Java or JVM point of view, what we are trying to achieve here it is we are using, so that means we are reusing, we are simply reusing or executing a predefined method from the string class. In what way? Just assigning that method reference, of class where it is available, and that we are just initializing to the functional interface reference. Then we are again calling converted to uppercase in the sense. So internally what it is going to happen now, whenever this line is executed, line number 20, so whenever this implementation is going to executed, so in this scenario it is going to invoke the method from the uppercase of string class. So finally we can see the entire string value is converted as uppercase in the second approach also. So that means the main agenda of method references here it is over the lambda expressions. I can simplify when solution is not available. If you want to define a solution, it's just define as part of a lambda expression initialization level. If a solution is already available as a predefined method or user defined as part of your logic, as part of your programs, then instead of again you are redefining the same logic by using lambda expressions with respect to functional interface implementations, you just take help of method references concept to invoke that existing method. We are taking help of method references. So I think you got the point now. It's all about reusing the existing methods. The point here it is. The point what here it is I'm trying to say, if you see here, this is what the logic overall here it is. So what it is saying, lambda expression is all about the implementation of abstract method what you defined as part of the functional interface. It's all about what implementation, the fresh implementation you are providing. But when it comes to method references, it is similar to equivalent to lambda expression. But only thing is method references is saying when already some methods are available and out of those methods one method is compatible to your abstract method, okay, signature, it's all about compatible to abstract method signature, then you just use that existing implementation method with the help of method references concept, so that the method implementation is directly implicated to the abstract method. So that means your this whatever the implementation method you have, whatever the implementation you are having, that is pointing to this abstract method implementation, and finally you are utilizing that functional interface reference, and you are executing or you are performing all the operations by using functional interfaces concepts. So that is what the main agenda of method references here it is. On a high level, reusing the existing method solutions by using method references concepts, instead of again you are declaring a way of lambda expressions, and inside that again you are defining the implementation, or maybe again lambda expression point of view also you may call same method from lambda expression also, but instead of doing all these steps, directly we can refer that method reference to the functional interface abstract method with the help of functional interfaces concept. So that is what all method references overview here it is. But at the same time, we know that in our Java we have a couple of different method types, right? So something like static methods, instance methods, right? So similarly here also, when we are working with the method references, we do have four types of method references. So that means the same method references is categorized as four types. One is reference to static methods. So that means in case the solution is available as part of the static methods. Second one is reference to instance methods. So the third type is reference to instance methods of arbitrary of given type. These three types belongs to the especially methods. But similarly, when it comes to constructors also, sometimes we used to consider constructors also similar to methods, but only thing is it will be executed while constructing the object, right? But it looks like somewhat methods only, right? So similarly, even to support constructor executions, assume your lambda expression, is internally taking care of some constructor execution to fulfill functional interface implementation, right? So in such case, even you can declare or you can define constructor reference with same delimiter here. So that means we are just initiating the constructor execution with the help of the delimiter references. So under the section called as method references. Okay, the fourth one is finally reference to the constructor. I will discuss each and every reference type here. Okay, when we are having static methods, what are the things we have to take care? Instance methods as well as the specific scenario instance methods of arbitrary object of given time. Then finally we will move to the referring the constructors also similar to methods. We will understand this one also. So before going into each and every one details, okay, we have to remember a couple of points here. So the first point here it is, the method references are always going to be declared as a implementation of abstract method of functional interface. So that means we cannot simply define method references when there is no concept of functional interface. Yeah. Before discussing about each and every individual reference type, okay, we have to remember a point very clearly is method references we have to define always as an implementation to the abstract method of functional interface. It's not like I can use anywhere else the respective method references when there is no relation with the functional interfaces. Okay, so that means we will see those points whether we can use the method references out of the box of functional interfaces concept. Okay, so now let's go back to the one by one. We will try to define a couple of examples with respect to every method reference type. For example, assume what I am doing here it is when it comes to reference to static methods. Generally in Java, what we will do, we will define sometimes static methods also inside our class. Now assume as a functional interface abstract method implementation, you're going to refer the static method of the class. That's the meaning of here it is. So when it comes to here, we are going to define the syntax like we are going to give class name and followed by we are going to give the respective method name of the static method. Okay, so this is how you are going to define, or you are going to initialize this reference to the functional interface implementation level. So let's say define a static method as part of the class, and I will try to use it. So to achieve this, what I'm trying to do, I'm trying to define a class called as employee class. Okay, I'm just making a little bit complex example. So as part of employee class, I'm defining a couple of properties. Okay, private integer ID and private string name of the person, and as well as I'm taking something like gender. So string gender, and I'm going to take one more property, double salary. Okay, so total four properties I have taken here. Let me define setter getter methods for this also. For this, I just defined setter getter methods for these properties. Okay, this is just simply a Java class, Pojo class, or we can call it as, right? Now here what I am doing, understand, inside the employee class, I am defining a static method. Okay, so now I'm defining a static method like validate employee details. So here I'm making sure mandatorily ID and name should be presented. Then only valid employee like I'm considering. Okay, so for that, I'm just writing a if statement, something like employee dot, okay, get ID is not equal to 0, and I'm writing like employee dot get name is not equal to none, right? So if everything is good, then I'm going to write down like return true. So he's a valid employee. In case false, then return false. That means he is not a valid employee. So this is how I return my logic here. So now I made it as a static method. Okay, sorry. I just made it as a static method. Okay, now what I'm going to do, I'm going to define a functional interface, and I would like to use that functional interface reference everywhere to make sure the given employee is a valid employee or not. I mean, that means the employee ID and name details are available or not. I have to verify. So for that, I'm writing one more new interface, functional interface, something like employee validation. Okay, I'm writing a functional interface, and I'm making this one also functional interface, so that I'm marking with an annotation at the rate functional interface, and I'm writing the return type as what? Boolean here. So is valid employee. Okay, and the method parameter is employee type we have to take. So I'm taking employee type. So what is the agenda of this abstract method? Here it is, taking in employee details and checking ID comma name available or not. Okay, if available, we are making sure like if available, or else false. This is what our expect. The return type is always boolean here. Now, what is the one thing we have to make sure here it is? Okay, let's define a method reference for the functional interface implementation of employee validation in our class. So I'm just taking one more main method class here, method references demo 2. Okay, so I'm just taking a main method here also. Now observe here what I'm doing. I'm not at all defining any lambda expression. I'm just going to define, okay, I'm going to define method reference of the static method. So what is our functional interface name now? Employee validation. Fine. Okay, so you're just doing the valid or not, right? Valid employee equal to, generally what we will do, we will immediately write down a lambda expression. Inside the lambda expression notation, you will define the logic like this to make sure ID and name is available or not. But this time you are already having a method which is performing same activity, then no need to write down the lambda expressions. So you just need to reuse the existing logic. Today it might be one or two lines. Tomorrow assume the same method is implemented with couple of use cases and it is proving it's a valid employee. Then why you have to write down same logic inside the lambda expression implementation? So instead of that, just reusing this method signature, this method implementation as part of functional interface implementation level. So now see what I'm doing. And whenever it comes to the method, what is this method? Static method. So in Java, we know that whenever it is a static method, okay, we will use static methods are accessed by the class name, right? So in Java, we will follow this rule. Similarly, here also, method references is saying, okay, go with employee. Method is belongs to the employee class, and the method name is what? So if you go and verify, the method name is validate employee details. Okay, validate employee details. So just close with the semicolon. If you see here, now in this overall solution, what you defined here it is, what we defined here it is, we are saying like this highlighted one, validate employee details. Okay, that means this entire thing, whatever you define. So whatever we defined here, the entire method implementation is going to become the implementation of functional interface called as employee validation abstract method. So in this case, this is the abstract method of functional interface, right? So this overall method implementation is going to take care of this method implementation. So this is how, internally it is just like it's all of referring, okay, implementation of abstract method. So functional interface, it is going to refer. So that's what, whenever you are calling again, now if you go back here and let's call and see sys out. So for that, what I'm doing, I'm validating one employee detail, validating employee details, validating employee details. So that means what I'm doing here, I'm creating a employee object first, employee emp1 equal to new employee. Fine. And I'm making sure employee, I'm passing to the valid employee implementation or functional interface. And what is the method we have defined is valid employee, and I'm passing the employee one. If you observe here, employee one is just initialized, but there are no employee IDs assigned or name is assigned. So that means we can consider employee one as a invalid employee. So it has to print now what? False. So he's not a valid employee. So that means it is going to be print false. So it is happening or not, see here. So just see, it is printing the false. So what happened in this scenario? Whenever this line is executed internally, so valid employee is all about our functional interface reference, and this reference is having, okay, internally the method reference, and it is representing the class called as employee, and from the employee class the method name is called as validate employee details. Here it is static method, that's why you are using class name colon and followed by the method name. So whenever this method is executed, immediately this employee one object is passing to this method here, and internally it is verifying employee details, and finally it is making the return value. Based on that, you can see false here. Now let's see, if I am passing one more employee details to the same functional interface implementation where we used method reference, what is going to happen? So what I'm doing, I'm just copy pasting same logic for, and I'm going to rename employee 2, and I'm going to make sure employee 2 dot set id, and assume his employee id is 123, and then followed by employee 2 dot set name, and I'm giving employee name as Dilip Singh. Okay, so now in this case, mandatory details like employee ID as well as employee name is available as part of the employee too. So I'm validating really this employee is a valid or not. So now in this case, what you're going to get? True, you're going to get, and let's understand here. Run as Java application. See here, you got the true. So that's what, in the overall context, what we understood here, instead of defining Lambda expression implementation, you are simply reusing the existing method what you defined as part of the employee class with the concept of method references. If it is a static method, when you are referring static method implementation, okay, to the functional interface abstract method, you have to use that respective class name before the delimiter where your static method is available. Okay, so simply static method from the employee class, this overall line is implementing. But one thing what we have to remember very clearly here, it is your, I will tell you one point here, it is your lamb abstract method of your functional interface syntax should be matched to the, so the syntax of your abstract method of functional interface should be matched to the method what you are referring from any another class or from the current class. Okay, it should be same syntax. It should be same syntax. Now, if you observe here, yes, both are pointing to the same method signature. Then only, okay, method signature in the sense, with respect to return type value, it should be same. And with respect to method parameters, what you are taking input parameters, that should be same. So you have to make sure method return type and as well as method parameters with respect to method signature, both are representing same, that then only you can assign that respective method in place of lambda expression, or you are just trying to make sure implementation of the abstract method. In case, for example, see here what I'm doing, the same formula, the same rule is applied for other method references also. Okay, so now if you, in case if you observe here what I'm doing, I'm making this one as a void. So that means my static method return type is void. I'm not returning any values as a void method. Okay, so let's see here, then in such case what is going to happen. So I'm just commenting out all the return statements. So now it's a static method. Okay, it's a static method, and it's all about a static method, and assume you're having logic here, and its return type is void. Save all the changes from the employee, but when it goes to the functional interface reference level and you told like employees validate employee details, in this in this case, why you are getting the compile time error, the type valid employee details employee, okay, from the functional interface abstract method, employee is void. So that means it is saying like abstract method is expecting boolean data type as a return type, but your validate employee details method is void data type. So there is no not matching with the method signature. So that's why it is a invalid method reference here. So you got the point, right? So what is the point we have to understand here? It is point number one. So the method which is referred, okay, should be matched method signature of functional interface abstract method. So it's very simple. The method which is referred, okay, should be matched to the method signature of functional interface abstract method. Otherwise, you cannot refer the methods to functional interface abstract methods level. So that is how we are making relation between method references in functional interfaces point of view. And now the statement whatever we have earlier, if you observe, okay, method references are special type of lambda expressions, in the sense instead of defining the lambda expressions, we are fulfilling all the things, okay, with the help of concrete implemented methods, and we are just referring those methods with same method signatures we are following, and we are just making sure referring those methods as a implementation to the abstract methods. Now this is all about the static method. Now what about the instance methods? Okay, let me do one thing. Let me correct my method signature. Okay, so I will make it as again boolean. Okay, so now again see here your compile time error is gone, and you can say like uh, employee 1 is false and employee 2 is true. Okay, good. Now in case this is all about the static method, right? So it's all about static method. That's why you are using class name colon colon method name. But when it comes to second option, it's all about references to the instance methods. So it's simple. Now it's the type itself representing what instance reference to the instance methods. So what you have to do here it is, in case your method is a non-static method, so that means assume in employee class you made it as a non-static method this time. So what it is, non-static method in the sense it's nothing but we can call it as instance method also. Now how we are going to call this method from the functional interface reference. If you see here, now you're getting a compile time error again. It's not like something, a static method. It's a non-static method. You cannot make sure the static reference from the non-static method point of view, right? So then what method references is saying, in case if it is non-static methods, okay, what you have to do is create. Generally in Java, what we will do? We will create instance for that class, and with that instance, we will execute the method, right? Similarly here also, create instance for the class, okay, where the method is located. So where it is located? Inside the employee class, right? Inside the employee class. In case if the method is located inside your current class called as method references demo, then you have to create object for this class, and that reference you are going to use as part of that object reference we are going to use here. Now what I'm doing, I'm going to create employee object, something like e equal to new employee. Okay, and here I am saying like, okay, let's take this e here and pass here. So see here now, it's all because of it's a non-static method. Non-static methods are always accessible by the instances of that class, right? Of the object of that class. So I created object for the employee, and I am using same object reference to declare or to define the method reference to make sure logic implementation of this functional interface internally. So that's all you have to take care when it is a non-static method. Okay, if you see here, now also it's a same behavior here it is. It is a same behavior it is. Yeah, so this is how we can refer instance methods with the help of instance name or object name when we are referring to the functional interface abstract method implementation. Okay, so now I'm going to discuss one more use case related to instance methods. So the point here it is, we can access instance methods with class name also. But it's not possible for every instance method accessing or referring with the class name. So that means here instead of instance name, I would like to give the class name. Okay, for example, if you see here, I'm just like it looks like static method references. Okay, but generally this is instance method, and I given class name here. It's saying some compile time error here. So that means it's not possible for every instance method accessing or referring with the class name. So that means we have to follow on one condition here. We can refer instance methods with the class reference, class name. So that means what is that condition here it is? So let me give you. So the condition here it is the method which we are referring from any class. So nothing but in our case employee class. Okay. So in our case what it is employee. Now that method should not contains any method arguments, and the same method should contain same return type value of abstract method which defined inside the functional interface. So that means now what is the point you understood? The method what the implementation method what you are going to refer with the class name, even though it is a non-static method, that method should not contain any method arguments. So that means zero method arguments has to be available as part of that method. And at the same time, one more compulsion what we have here it is, and the same method return type. So that means the method what you are referring from the employee class, that method return type should be equal to the method return type of abstract method which you defined inside the abstract method. So that means in our case, if you go to the functional interface, we define return type as boolean. But whatever the method we are trying to access with the class name, even though it is an instance method, that means, for example, see here what I am doing. I'm making sure my return type as a boolean here. The reason is what? The functional interface return type is what? Abstract method return type is boolean. So that's why I made return type as also boolean. And I'm writing a new method, something like valid salary or not. Okay, valid salary, something like that. I'm writing a method here. And if you observe here, return, okay, what I'm doing, I'm just taking current object, this dot get salary, okay, greater than 0. So that means true. So it's a valid salary in case 0 value or equal to 0. Okay. So if it is maybe 0 or less than 0, then it is all about false. So in this way, I'm just determining the respective employee is having valid salary or not. If you observe here, I have no method arguments. So 0 method parameters I defined here. Okay. But the return type is what? Boolean data type. So you may get result as true or false. And this return type, this is what the condition we understood now. The method which we are referring from the class employee. Now, yes, this method is okay, eligible accessing with the help of class name of employee, even though it is a non-static method. The reason is no arguments, and as well as the return type of this method is matching with the return type of functional interface. Now this method you can access with the help of class name, or you can refer with the help of class name. So see here what I'm doing. I'm creating functional interface. What we have, what is the functional interface we have? Employee validation, right? So okay, so something like salary validation or whatever it is, I'm just taking and I'm making, see now I'm using class name now, employee. What is that? Class name. So employee and delimiter of method reference, and I'm referring valid salary method. Okay, and just save it semicolon. Now see, yes, you can refer instance methods with the class name, but on one condition, what? This method doesn't contain any arguments, and as well as this method return type is matching to the functional interface abstract method, then you can access. Now let me validate one of our existing employee. See, for example, I'm giving employee 2 here. For this instance of functional interface, what is the method we define? Is valid employee, right? So I define what? Employee 2. So this employee 2 is passing to the valid salary as a this object, current object, and I'm making like greater than 0, then valid salary, otherwise false. Okay, now let me execute this scenario and observe what is the output we are going to get in this scenario. Okay, so see here, you got false. Yes, obviously, the reason is you are not initialized any salary for the employee too. That's why it's 0, you got the false. Now let me make it as some salary for the same person, set salary. Okay, and I'm making something like 50,000 for the person. Now let me execute. Now based on our method execution result, it has to be true. So now salary wise also, employee 2 is a valid salary or valid salary he is having, right? So this is how you can make sure accessing instance methods with the class reference, with the class name, by using method references, whatever the condition we have, here it is. Okay, so only in this specific scenario you can access. Other than that, if your method is having, okay, like this way approach, here what is happening, this method is having method arguments, one method parameter you define, right? Whatever it is. So in this case, yes, 100% you cannot use again class name employee. So see, even I am using class name, we are getting compile time error here. So that's all you have to understand how we are accessing instance methods, sometimes by using instance reference or sometimes by using class reference. Okay. So now let's move to the third method references type called as reference to the instance methods of arbitrary object of given type. So we need to little bit focus on this method reference type now. That is, we need to understand now what is the meaning of instance methods of arbitrary objects of given type here. Okay. So let's see here, I'm taking an example and we need to understand internally what is the meaning of arbitrary objects and initiating or referring the instance methods as part of functional interface abstract method implementation. Okay, now if you go to the arrays, predefined class called as arrays, and if you observe there is a method available called as sort method with overloaded something like you are passing array of values and you are getting the sorting values based on the comparator implementation, right? So now what I'm doing here, I'm going to pass set of array values here. So that means what I will do, I'm just taking a string array values. We can take any type of array values generally. Okay. So now values equal to what I'm doing, I'm just defining couple of array values here. So here now I have array of string values and I'm going to sort these string array values, okay, in an ascending order and by using a sort method of arrays class. Okay, for that what you're doing, you're just passing values attribute here. And if you observe the second method parameter here, it is what guys? Comparator. So it's what? Comparator is the second method parameter. And if you go to the comparator interface, okay, so that means let me open the comparator now. If you see here, comparator from our Java. If you observe here, what is this? We have a abstract method called as compare abstract method. So what the method signature of abstract method is what? The return value is integer when it is comparing object 1 comma object 2. So nothing but type 1 comma type 2. So here you can pass any data type values. So that means integer values, string values, okay, whatever the values you have to pass here, any type of values we can pass. That's the meaning of compare here it is. So and this is what? Functional interface. So that means when we know that now when it comes to functional interface, we have to provide implementation for this abstract method and then we can use it. Now in this scenario, what I'm doing, see here. So now I'm providing implementation for the compare abstract method of comparator. Okay. So with lambda expression, I'm doing. So I'm just taking object 1 comma object 2, right? And followed by, and I'm comparing. So if you observe here, what are the data type values we are having? String data type values. So now I'm considering with respect to comparator abstract method of compare. So you can pass any data type. So in this case, the objects what we are passing like object 1 comma object 2 for the compare method. So those are all I'm just calling it as arbitrary objects. So if you, what I'm doing here, see now object 1 dot, okay, and if you observe here all these methods are belongs to what? String class. So these o1 comma o2 is okay, becoming part of string data type values or string objects. So now I'm calling object 1 comma or object 2 or as arbitrary objects. So that means if you observe here again, I'm calling a method called as compare to ignore case. So that means I'm just comparing string 1 value with the string 2 value by calling the instance method of string class called as compare to ignore case. So in this case, what happened here it is this logic, whatever I provided with lambda expression, okay, it is replacing the logic of the comparator compare abstract method. So that means even if you're providing implementation for this compare abstract method, generally how we are going to write down two parameters and then we will return a integer value. Now here also the predefined method belongs to the string class called as compare to ignore case is taking two values, and let me open this method also, okay, from this string class. If you see here compare to ignore case, so it's comparing internally the current string value with the provided string value. Total two string values are taking here. And if you observe here, even internally they are also okay taking care of comparator. They are just okay taking again a comparator and they are comparing the values as part of that method. Okay, so just only thing is what we have to understand, this method belongs to the string class, this instance method, and we are comparing string value 1 comma string value 2, and I'm using string class predefined method here. But the overall whatever I defined here, this is all completely replacing with the, so if you observe here, this is just replacing the implementation of comparator compare method also. So if you just taken it, so it is replacing the implementation of compare method. So if you observe here, lambda expression for this object 1 comma object 2 and o1 dot, so whatever it is, even this method return type is what, integer value, even compare method return type is integer value. So it's replacing the functionality, of compare abstract method. So it is, the return type is also integer for the compare to ignore case. So this is what calling as arbitrary objects, and you are using method from the arbitrary type called as string, even though this overall implementation is representing comparator functional interface abstract method. Okay, so now let me execute, or let me print my values, everything is sorted or not. Okay, let's take a simple for loop. I'm just taking string values and I'm just making sure like sys out of, okay, every string has to be printed. We are just verifying everything is sorted or not. Okay, if you observe here, yes, it's clearly sorted. Dilip, Java, and methods and references and Spring. The given order is Spring in the third place. Now Spring came into the last place. So that means everything is sorted here. So this is all what Lambda implementation for the comparator interface for the compare method, right? Now, but even though we provided implementation with Lambda expression, but the agenda of method references is what? So instead of providing again implementation like this, okay, as part of Lambda expression, and internally you're calling the either predefined method or user defined method from the Lambda expression notation. Instead of all these things, what we can do? So now I'm just making the same line in this format, okay, with method references point of view. So what I'm doing here, I'm just removing this overall and I'm making like string colon colon, and I'm making compare to ignore case. Compare to ignore case. Now observe here. So you are utilizing predefined method called as compare to ignore case, and from the string class it is taking two input values again. Even if you go here also, this is also comparing current value and current object and as well as given object here also. Okay, so that's why you can call, you can define method reference. So actual sort method parameter is comparator implementation, but so as part of comparator implementation point of view, we are calling the string compare to ignore case method, and it's overriding the functionality of compare method from the comparator interface. Okay, so now let me see again the same result is coming or not. Yes, if you see delete Java methods references and Spring, yes, even the values are sorted. So this is all calling as, okay, arbitrary type, referring the instance methods of arbitrary objects of given type. So given type in the sense string I given today, tomorrow I can give one more data type also here. So I maybe I can write down something like employee objects also here. I can implement. Okay, so that is what the meaning of arbitrary objects of given type and referring the instance methods. So with this, we are done with the different types of methods like static and non-static methods, how we are referring with respect to functional interfaces implementation point of view, right? So similarly, even Java 8 is provided same kind of concept called as constructor references as a fourth option in the same concept. So that means whatever the fourth option we are having, it's all completely related to the constructors. So let's discuss what is the point of, okay, reference to the constructor. What is the meaning of it is? It's very simple again. So instead of, okay, defining logic as part of our functional interfaces implementations level, okay, if you are having anything going to be executed, something related to constructor references, we can do that. Okay, so now let's take a scenario related to constructor references. Okay, so now I'm creating a functional interface now, and I'm calling functional interface name as something like get employee instance. And here what I'm doing, if you observe here, so this is a functional interface. Fine, even we know that. And I'm making sure here my return type is what? Employee. And I'm making get employee, and I'm just passing something like string or integer id comma, okay, string name. So I just defined an abstract method called as get employee, and the return type is employee type, and I'm passing two method arguments id comma name, and it's a functional interface now. So in this case, what I'm going to do now, go to the employee class, and if you observe here, I don't have any thing related to constructor, right? So let's see here. First, let me define a constructor here, and then we will understand how constructor references are going to be useful. Okay, so what I'm doing, let me define a constructor here with 0 parameters. Okay, and so here sys out of this is employee constructor with no data. Okay, fine. And I'm observe here now what I'm going to do. Okay, so I will define, now I'm defining one more constructor with two values, something like integer, okay, id, employee id, comma, and followed by string employee name, something a property I taken. So this is employee constructor with data I just taken here. And what I'm doing here, so I'm just passing these values to our instance variables, like this dot id equal to the employee id, and just I'm passing this dot name is equal to name. So that means what I did in my employee class, total I created two constructors. One is with 0 parameters and one is two parameter constructor of the employee. Now if you observe the functional interface, okay, and the functional interface abstract method, final return value or result should be always a employee type. So that means now what I'm going to do here, just understand here, I'm creating a new class constructor demo. Okay, fine. So I'm just taking a main method. So let's see here what I'm doing. So how I'm referring the constructor which defined inside the employee class for the functional interface get employee instance, okay, as part of abstract method implementation. So what is my interface here? Get employee instance. Okay, okay, fine. And I'm just taking like employee equal to, if you observe here what I'm doing, employee, and I'm followed by the colon colon. Generally we know that, right? So in Java, whenever we are creating objects, generally how can we create employee e equal to new employee? So that means to initiate the constructor, generally we will use the keyword called as new keyword, right? Similarly, what I'm doing here, so defining same new keyword as part of constructor reference. So that means you are telling, we are configuring like, so whenever I initiated the abstract method implementation from the functional interface, okay, so this with this instance of functional interface, internally it has to execute a constructor from the employee class. So that is what the meaning of it is. So that means if you see here, I'm just taking instance of functional interface and I'm calling the abstract method what were available as part of functional interface and whatever the now what is the point here it is. So let me configure some data first and I'm giving something like employee name as Dilip Singh. Okay. So in this case, if you observe here, what is the return type of get employee method? Employee type. Okay, so it's returning employee object. So let's do one thing. I'll tell you what is happening internally. Okay, so in this case, what's happening here it is, you are referring a constructor from the class called as employee and by using a keyword called as new keyword after the delimiter, right? So that means what you are trying to say here it is, whenever you are calling the abstract method implementation of functional interface, so internally by taking all these details, okay, it is going to execute the constructor from the employee class. So now, okay, that is fine. So let me execute and let's see, is it now? So you know that whenever a constructor is executed, that means an employee object is created. And the same employee object is whatever is created by the constructor execution, that is what written from this method. So that means the functional interface abstract method is internally when you are invoking that, so internally executing the constructor and whatever the object is created after executing the constructor, that object is being written again here. So now let me see really the things are available or not. So what I'm going to do, employee dot get, so I'm going to write down id so that it has to print 100 and as well as if name also I'm going to print. Okay, so see here get name. Okay, so let's execute now, run as Java application. If you see here, this is an employee constructor. So that means a constructor is executed with data. So if you go to the employee class, then employee, this constructor is executed. So this constructor is executed and the data is initialized as part of constructor, whatever you provided from the abstract method of functional interface. So this is how internally you are initializing the constructor for the abstract method of functional interface. Now my question here it is, okay, that's fine, it's initiated. But how Java is knowing that which constructor has to be executed? So when you're calling this, okay, so you're saying like a constructor has to be executed. But the point here it is, how Java knowing that which constructor has to be executed? So internally, generally, what these guys are doing, they are comparing the number of parameters what you are taking as part of the abstract method. So that means in the abstract method, how many two parameters we have now? Total two method parameters. You define two method parameters, right? So that's why they are executed, okay, the two parameterized constructor here. Now for example, see here, if I'm making this one as a one parameterized constructor and you don't have any constructor inside the employee with one parameter called as a integer value, right? So now in this case, what is going to happen? Understand here. Okay, so if you observe here, even here itself it is saying like a compile time error. So it was saying like there is no constructor with one parameter called as employee integer. So that means you have to make sure, what is the rule here it is, as part of constructor references, make sure abstract method parameters are part of constructor definition in the same order. That is also. So that means whatever you are just making as part of abstract method level, so the same parameters you have to define again a constructor with respective class, then only it will work. Now see if you what I can do, now let me define one more constructor with integer id, okay, and let me see here, save it and come back here. Now save it, see, now you got the, now your compile time error is resolved here. So what is the point you understood now? So based on the abstract method parameters, so that respective constructor will be executed whatever the class you referred here. So if you don't have that respective constructor, the equal number of parameters and same parameters in the constructor implementation level, then you are going to get the compile time error. Now in this case, which constructor will be executed? So definitely it will execute the constructor with this up. Okay, this constructor will be executed. So the reason is what? So if you go to here, if you go here, so the abstract method is defined with only integer id value, so that only integer constructor will be executed in this scenario when you are calling the abstract method from this interface. Okay, so if you see here, anyway, I will just try to execute one more time, and I'm passing some value 111 here. Okay, and you're going to get again employee object, and observe which constructor is executed. Now let me write down this out here also. This is only id value initialized. Okay, so if you see here now, run as Java application. See, this is only id value initialized. So that means only that respective constructor is executed. So what is the point we understood now finally? Make sure abstract method parameters are part of constructor definition. So with respect to what? Order and types. Then only you can define constructor references, or you are initializing constructors references as part of functional interface abstract method implementation. Okay, so this is all about the method references and constructor references, which is introduced as part of Java 8 version onwards. And we know that these concepts are nowadays being used in every level. Okay, so now what I will do in the next session, I will make of each and every existing functional interface. Like we have couple of things like predicate, supplier, consumer, and all. I will make a session for all existing predefined functional interfaces, and we will try to understand the purpose of every existing functional interface which are specifically provided by the Java language. Predefined functional interface purpose also. Okay, so that's all comes under functional programming. So once we are understanding the predefined functional interfaces as well as couple of things whatever we completed in this session and even previous sessions, the functional interfaces point of view, lambda expressions point of view, these are all comes under the functional programming. Okay, so you know the importance of functional programming, how things are being used, especially the most popular concept called as stream API. So as part of stream API we are using definitely everywhere as okay, what we are using lambda expressions and method references. So where it is all placeholders of functional interface implementations. Okay, then I will make a good session for stream API also. Okay, so that means before stream API we should have all this knowledge. So that's why we need to go through, or we need to revise everything before understanding the stream API thoroughly. So thank you, thanks for watching, and let's connect with the next session.